we need to know whether Jack and Rose would have survived long enough to be rescued. To find out, we're going to have to do some high-tech hypothermic testing to answer that question.
And the crucial reference for those tests is how long did it take for rescue?
All right, James, so for our hypothermia testing, we need to know exactly how long it took Rose to be rescued, but in the film it's a little ambiguous. What's the answer?
We show her getting rescued by 5th Officer Lowe, and he, according to survivor testimony, started his search about 20 minutes after the ship sank.
And how long did he search for?
About 45 minutes.
Okay, so he could have found her anywhere between 20 and 65 minutes after she hits the water.
Right, but let's push it toward the back end because we show her in the movie being one of the last ones rescued. He's almost ready to give up when he hears her whistle.
So let's say she blows her whistle at 63 minutes. Does that sound reasonable?
Yeah, perfect.
Cue Dr. Frankenheineman.
It's like I just picked up all of my blood veins and laid them on the table. All this plumbing right here is the cardiovascular system of our dummy. Now the idea is to supply the same amount of heat to this dummy as your metabolism supplies you. So to do that, we're going to have a reservoir of blood, which is basically water. That water will be picked up by this pump and pumped into the intake of our vascular system here. It's alive! And it'll just keep circulating. It's beating just like a heart. I'd say we're in business.
That's the heart and pump system. But how will Thermo Man generate heat like a real human?
The metabolism of our dummy in this case is replaced by this 300-watt fish tank heater. It will be able, under neutral conditions, to keep his body temperature at 98.6 degrees Fahrenheit. When we immerse him, however, it won't be able to keep up and his body temperature will start to drop. We'll monitor that on this, a thermocouple embedded right into the intake tube, so we'll be able to see directly how quickly his body temperature drops.
So, Thermo Man's gelatin flesh has been poured into his human-shaped mold, surrounding and supporting his copper veins. And once Jamie tops that off with a head...
Oh, look at you, you handsome devil.
And cracks open the mold...
There it goes.
Oh! Adam and Jamie, cyborg midwives.
Our stand-in Jack and Rose is looking good.
That looks creepy and upsetting and awesome all at the same time.
And once they turn it on, and the water flooding through the copper coils is at body temperature, it looks even better.
Hey, Adam, come check this out.
Oh!
Look at the coils.
That is so cool. It is totally working. It also looks like it's heating up the flesh around the coils.
You can see exactly where it's heating it up. Well, we've got Thermo Boy here up to 98.6. So it would seem that our cardiovascular system is up to the task of providing enough heat to our body to be equivalent to a normal human.
Everything's working. Ah, that's awesome.
Now it's time for him to go for a little swim.
What happens when you haven't got access to waves or a green screen? Supposedly, you try rockets. But so far, surf is far from up. And that's the bad news for Tori, because he's desperate to test this myth himself. However, our team of budding rocket scientists has a plan.
All right, so it looks like our fears were confirmed. The big rocket just has too much of an initial hit for him to surf. But I want to give him the benefit of the doubt. Maybe he did some sort of configuration of small rockets.
You know, that's not a bad idea. I mean, we could take the small rockets, configure them in a way so we get a slow ramp up, and it's not too big of a thrust to knock the surfer off, and we could extend the ride to get that 30-second ride that the myth talks about.
You know what? We could start by pulling you on a skateboard, faster and faster, and find out what the maximum acceleration is that you can hang on without falling off.
Well, that's a great idea, and then we could use that number as our rocket threshold. Whenever you have to wear padding for science, things generally go horribly wrong.
So to find out the maximum G-force that Tori can handle...
What could possibly go wrong?
Without falling over, they're going to yank Tori faster. And faster.
Wow, that was intense.
Until the acceleration delivers a G-force he can't handle.
Tori acceleration at 60% capacity in 3, 2, 1.
Oh, whoa!
Just like that.
Okay, so this right here is the information from the data logger. Along this axis is time, and along this axis is the G load. You can see here the peak is at 0.8 Gs. So what this means is that none of our rocket tests should exceed 0.8 Gs. That way, we know that he'll be able to hang on.
And that all means to get this myth off the ground, they require a surfboard rocket rig that'll have a thrust below 0.8 Gs, but still hit the myth-specified 20 miles an hour for 30 seconds.
Rocket board.
And the plan is to use several banks of smaller rockets in a series of ignitions.
Each of these model rockets give us around 2 pounds of thrust. Now, our surfer and the surfboard weigh 180 pounds, and we need to get that weight up to 20 miles an hour. So we're going to need 20 model rockets for that initial stage. Now, if this works, then we need to continue that thrust because these only last for 3 seconds. At that point, we're going to have to figure out how many rockets we need for the second stage and at what time that second stage needs to go off.
With the surfboard prepped and Tori's rockets ready to roll, it's down to Treasure Island to find out if this myth has struck gold.
Why does this thing weigh so much?
Because you're a fat guy.
So here's our somewhat complicated setup for today's experiment. First of all, we're going to drape a guide cable the entire length of this somewhat murky water channel. Then we'll put the surfboard down in there, and we have touchdown. And connect it up to the guide cable.
I think I'm going to need an antibacterial shower after this.
Next, we'll install the rockets, and then we're ready to go. We'll fire them off.
All right, the rockets are wired.
To collect data, we have our onboard accelerometer and our high-speed camera.
Tori's weight equivalent is strapped to the surfboard, and the 20 rocket stage 1 is ready for ignition. It's time for launch.
All right, this is acceleration test for Rocket Surfer. All right, here we go in 3, 2, 1, firing. Awesome! Oh my gosh, that was beautiful.
It was a slow, controlled acceleration, and with a peak velocity close to the 20 miles an hour they need, this myth is on the up and up.
This is great. We got a measurement of 0.6 Gs on takeoff. Now, it's a little bit less than our predicted model, but the important thing is that it's below 0.8 Gs, which means Tori will be able to hang on in that situation. Now it's on to the two-stage test.
So now that we know how many rockets we need to push my weight 20 miles an hour, just like the myth says, it's time to figure out how to sustain that ride for 30 seconds. So what I'm going to do is take a second bank of rockets and use a time fuse to extend the ride. All right, rockets are loaded. All right, here we go. This is two-stage rocket on the surfboard. In 3, 2, 1, fire!
That's the sound of happy rocket scientists. Stage 1 fired and produced a gentle rideable start. Then Stage 2 kicked in to extend the ride, just as they'd hoped.
So we learned two important pieces of information today. First, that 20 rockets is enough to give us a startup G load of 0.6 G, which is something that Tori should be able to ride. Second, we can sustain our ride and maintain our speed by delaying the firing of the next stage by 2 seconds.
Now we just need to add more stages to get that 30-second ride. The real question is, how much fun is it going to be when I ride it?
Welcome back. I'm Jim Cameron, and this is Mythbusters. Adam and Jamie are manning the lifeboats for the most requested tall tale that the guys have ever tackled.
Remember, kids, in order to perform science, you need patience. Patience willing to be subjected to dangerous experiments.
And the patient willing to take a lethally cold dip is Thermo Man.
The question is, could Rose and Jack have survived on that piece of wood until rescue came? And it all boils down to how long the human body can stave off hypothermia. Now, we know medically how long the human body can stave off hypothermia if it's immersed in water. But if you're out of the water in wet clothes and the air is the same temperature, how long then? Is there a difference? My intuition tells me that there is, but that's what we are testing for.
Gotta add a little more North Atlantic.
First, we're going to immerse our fully clothed dummy in 29-degree Fahrenheit water and see how long it takes for him to reach hypothermia.
Can I just tell you, I'm so glad it's not me doing this test.
Then we're going to pull him out, warm him up to his normal temperature, and put him in his wet clothing in 29-degree Fahrenheit air and see how long it takes for him to reach hypothermia there.
So that's the cold bath plan. But is it accurate?
So what can you tell me about the climatic conditions Rose and Jack were facing?
Well, it turns out there were really good records from the night of the sinking, and the water temperature would have been hovering, just below freezing, so around 28, 29 degrees Fahrenheit.
Hence the icebergs.
Yeah, exactly. But what's interesting is the air temperature was almost identical. So it was about 33 degrees at the time of the collision, but by the time of Rose's rescue, about 3 a.m., it had come down to 29 degrees. So your 29-degree comparison would be right on.
Excellent.
So with the director's seal of approval, Jack is warm to human body temperature and ready for action.
Let's go. The conduction of this test is going to be pretty straightforward. Jamie, with a little assistance, is going to dunk our dummy in the cold North Atlantic water. I will be monitoring his temperature drop every 30 seconds until he's dead.
And after 10 minutes, with Thermo Boy's temperature dropping significantly, we catch a rare glimpse of Jamie's tender side.
How you doing there, little buddy?
Real tender.
Sweet cheeks.
As you move towards 96 degrees, you're shivering. As you move towards 91 degrees, you're shivering violently and uncontrollably. All this is a good thing because that's what your body is doing to keep you warm and alive. As you go beyond 91 degrees, you stop shivering, and that's a bad thing.
Ow! That water's cold.
Our body is at 85 degrees at this point. He is on a solid trajectory towards dying, experiencing almost full immobility and stupor.
Yep, and the key symptom at this stage of hypothermia, loss of motor control, means Jack, unable to hang onto the board, would have drowned by now.
What's your diagnosis, Dr. Heidemann?
He's dead.
A diagnosis reached long before the 63-minute rescue time. So far, so good for the survival times portrayed in the movie.
Remember, kids, the only difference between screwing around and science is writing it down.
Now, with Thermo Man warm back up to body temperature, what about survival on the board?
3, 2, 1, here we go.
Out of the water, in 29-degree air, would Rose have survived to die warm in her bed? If Jack could have got on board, would there have been a happy ending to the biggest disaster movie of all time?
This is interesting. In 23 minutes, our guy out of the water is at 90.7 degrees. At the same time, in the cold water, he was at 90 degrees. So we're pretty much almost neck and neck between both tests.
So, in terms of retaining heat, there's only the slightest advantage to being on the board, except in one crucial respect.
I should point out that Thermo Boy is just past the 85-degree mark, which is the point that he would be in a stupor and immobile. Now, that means that if he was in the water, he'd probably drown. But he's not. He's on a board. He's in air. So he's got kind of a grace period here where he's not dead yet. He's got a few degrees to go before that happens. He might get rescued.
Yep, below 82 degrees, death is a deadly certainty. But at the time of rescue, Thermo Man's core temperature was above that. So, again, the movie is accurate. Rose would have been alive, just barely, when the lifeboat arrived.
So what do we take away from all this? Well, if you're in sub-zero water and weather, the difference between being in that water or out of it and wet is pretty small, but there is an advantage to being out of the water. And critically, once you pass 85 degrees core body temperature, you can no longer move your limbs. If you're in the water when that happens, you are nothing but a weight heading to the bottom of the sea. If you are on your board or boat or whatever you've got, you might just last until rescue.
Quite simply, Jack's only chance of survival is to get on the board. But could he? There's only one way to answer that question. Adam and Jamie,
Don't call me Rose,
are getting wet and intimate for science. Next on Mythbusters.
What could possibly go wrong?
Is Tori really going to ride a rocket-powered surfboard?